All right, so continuity. If you recall from last year, our definition of continuity said that a function is continuous at a point if the limit as x approaches that value is equal to the function evaluated at that value. For two variables, very similar idea. A function f of two variables is called continuous at a comma b if the limit as xy approaches a comma b of that function is actually equal to the value of that function, f of a comma b. We say that f is continuous on D, its domain, if f is continuous at every point a, b in the domain. Very similar definitions, very similar definitions. So, continuity facts for multivariable functions. All polynomials are continuous on R squared. Any rational function is continuous on its domain. Remember, we have to get rid of places where the denominator equals 0. Sums, differences, products, quotients, of continuous functions, are continuous on their domains. For a product like this, so f is equal to some g times some h, where g is a function of x, h is a function of y, is continuous at ab if g of x is continuous at a, and h of y is continuous at b. Then compositions, when f is equal to some g of h of xy, is continuous if the inner function is continuous at that value, and then the outer function is continuous at the result of the inside function. So that's just having to evaluate the inside first. And then you get a value, and you need to make sure that g is also continuous at that result. So, looking at a couple of more straightforward examples, do we have continuous functions? So when we look at f of xy equals 3x squared y to the fifth, let's look right here. We have a function of g, 3x squared, which is a polynomial. So g is continuous everywhere. We have a function of h, y to the fifth, also a polynomial, so we know h is continuous everywhere. And because f is a product of two continuous functions, then f is continuous on all of R squared. Remember, we're doing things in a comma b now. So it's not just all real numbers, it's all pairs of all real numbers. Looking at our next example, this is a composition I can spell. When we look at the inner function, let's call it h of xy equals 3x squared y to the fifth, which we just did. It's continuous everywhere. So then let's think about what g of u is. G of u is equal to sine of whatever value that thing spits out. What do we know about our function sine of a value? This thing is continuous everywhere. So we have our composite function f of x comma y is continuous on all of R squared. Our last example, a piecewise function. We're very used to these things not always being continuous. So let's check this out. So first of all, g of 0, 0 is equal to 0. So g is defined at 0, 0. Part of the way we think about our definition of continuity. Maybe I should say it again, just in case. Remember that a function is continuous if the limit of that function as you approach that ordered pair is actually equal to f evaluated at that ordered pair. So the limit has to exist, the function has to be defined at that point, and they have to equal each other for this thing to be continuous. So we just picked out part of it. It is defined. From example 2 earlier in our notes, the limit as xy approaches 0, 0 of our function g of xy. So we're now only looking at that part right there because we're approaching 0, 0, not equal to it. So that's where we are if we're approaching. We're using that top branch of that piecewise function. We know that that limit does not exist. We have to scroll, sorry about moving really fast, where's example 2? There it is. We found that along different pathways, our limits are different, so we concluded that the limit of that function does not exist. So that, of course, breaks part of our continuity definition. The limit has to exist for something to be continuous. So what can we conclude here? That g of xy is discontinuous at 0, 0. So where can we talk about the continuity of g of xy? It's going to be continuous everywhere else. 0, 0 is a problem, but everywhere else, g of x is continuous on its domain. And what is its domain? It's all sets of ordered pairs x comma y such that our ordered pair is not equal to 0, 0. All right, and there we have it. Continuity. We can talk about anything you'd like when we return on Monday. I would tell you to give a glance at your homework to see if you find any problems that you are uncomfortable with doing. Don't forget to look in your homework packet for the part 1 of chapter 14, and I hope everyone has a wonderful weekend.